Close your eyes, and let's drift upward, up through the atmosphere, beyond the clouds, past the edge of our world, and into the infinite expanse of space. Our journey begins here, at home, on a planet we call Earth. But Earth is not simply floating alone in darkness. We are part of something much larger, a cosmic address that stretches outward in layers. We live on Earth, which orbits the Sun, which resides in the Milky Way galaxy, which is part of the local group of galaxies, which belongs to the Virgo supercluster, which is itself just one small part of the observable universe. Our address in the cosmos is vast and humbling, a reminder that we are both infinitely small and infinitely connected to everything around us. Let's begin with our nearest celestial neighbor, the Moon, floating peacefully just 238,855 miles away from Earth. This seems like a great distance, yet in cosmic terms, the Moon is practically touching us. If Earth were the size of a basketball, the Moon would be the size of a tennis ball, hovering just 23 feet away. The Moon is slowly drifting away from us, moving approximately 1.5 inches farther from Earth each year. Millions of years from now, the Moon will be a more distant companion, and the tides it creates in our oceans will be gentler than they are today. The Moon has another gift that gives us beyond its gentle light: it stabilizes Earth's rotation. Without the Moon's gravitational influence, Earth would wobble chaotically on its axis, causing wild swings in climate that would make life as we know it nearly impossible. Our Moon acts as a cosmic anchor, keeping our planet steady and our seasons regular, a silent guardian that has watched over Earth for more than 4 billion years. Now let yourself drift outward to our Sun, the star at the center of our solar system. The Sun is so large that you could fit 1.3 million Earths inside it. Yet despite its enormous size, the Sun is actually quite an ordinary star, a middle-aged, medium-sized yellow dwarf star, one of hundreds of billions in our galaxy. What makes it special is simply that it's ours, the source of warmth and light that makes life on Earth possible. The light that reaches you from the Sun, warming your face on a summer day, began its journey in the Sun's core. But that journey is far longer than you might imagine. In the core, where nuclear fusion occurs, photons of light are created. However, the Sun is so dense that these photons bounce around inside it for an average of 100,000 to 200,000 years before finally reaching the surface and escaping into space. Once free, that same light takes just 8 minutes and 20 seconds to travel the 93 million miles to Earth. So when you feel sunlight on your skin, you're touching energy that began its journey thousands of centuries ago. Our Sun has been burning for about 4.6 billion years, and it has approximately 5 billion years of life remaining. When its fuel finally runs out, the Sun will expand into a red giant, growing so large it will likely engulf Mercury, Venus, and possibly Earth. But this transformation is so far in the future that entire epochs of evolution could occur before then. For now, our Sun burns steadily and reliably, a constant presence in our sky. Let's drift now to consider the nature of space itself. Space is not truly empty, as we often imagine. Even in the vast distances between stars, there are atoms floating, about 1 hydrogen atom per cubic centimeter in interstellar space. It's the closest thing to a perfect vacuum that exists, yet it's not absolute nothingness. Space also has a temperature. Far from any star, in the depths between galaxies, space sits at approximately -454 degrees Fahrenheit, just 2.7 degrees above absolute zero. This is the cosmic microwave background radiation, the faint afterglow of the Big Bang itself, still detectable 13.8 billion years after the universe began. Here's something that may surprise you as you relax: there is no sound in space. On Earth, sound travels through air, vibrations moving through molecules from one to another. But in the near vacuum of space, there aren't enough molecules to carry sound waves. An explosion, no matter how large, would occur in complete silence. Astronauts in space can only communicate through radio waves or by touching helmets together, allowing vibrations to pass through the solid material. The universe is a silent cathedral, vast and quiet, where light dances but sound cannot follow. As you breathe slowly and deeply, consider the speed of light, approximately 186,282 miles per second. Nothing in the universe can travel faster than this. It's not just a speed limit for spaceships, it's a fundamental property of reality itself. Light from the moon takes 1.3 seconds to reach Earth. Light from the sun takes those 8 minutes we mentioned. Light from the nearest star beyond our sun, Proxima Centauri, takes 4.24 years. This means when we look at distant objects in space, we're looking back in time. The universe is not just vast in space, but vast in time, and every star you see in the night sky is showing you its past, not its present. Rest now in this knowledge, floating peacefully in your mind among the stars, where time and space stretch infinitely outward, and everything is connected by the gentle, eternal light. Breathe slowly and let yourself drift deeper into the cosmos, where each moment stretches across light years and peace settles over the infinite expanse. Let us journey now to the planets of our solar system, those wandering companions that share the sun's embrace with Earth. There are 8 planets orbiting our star, and each one is a unique world with its own story. But here's something remarkable: despite their differences, all the planets orbit the sun in roughly the same flat plane, like marbles rolling on a vast, invisible table. This isn't coincidence, it's the remnant of the spinning disk of gas and dust from which our solar system formed 4.6 billion years ago. Everything we see, from the smallest asteroid to the largest planet, was born from that ancient, swirling cloud. The closest planet to the Sun is Mercury, a small, cratered world that experiences the most extreme temperature variations of any planet in our solar system. During the day, Mercury's surface can reach a scorching 800 degrees Fahrenheit. At night, with no atmosphere to trap heat, temperatures plummet to minus 290 degrees Fahrenheit. That's a swing of over 1,000 degrees between day and night. Mercury also has the most eccentric orbit of any planet, racing around the Sun in just 88 Earth days while rotating so slowly that one Mercury day lasts 59 Earth days. As you relax even deeper, picture Venus, our neighboring world, often called Earth's twin because of its similar size. Yet Venus is nothing like Earth. Hidden beneath thick clouds of sulfuric acid, Venus has a surface hot enough to melt lead, about 900 degrees Fahrenheit. Its atmospheric pressure is 92 times greater than Earth's, equivalent to being 3,000 feet underwater. Most remarkably, Venus rotates backward compared to most planets in our solar system, spinning clockwise when viewed from above. Scientists believe a massive collision early in Venus's history knocked it into this retrograde rotation. On Venus, the sun rises in the west and sets in the east, a topsy-turvy world where one day lasts longer than 1 year. Let your thoughts drift now to Mars, the red planet, colored by iron oxide rust covering its surface. Mars is about half the size of Earth and has the largest volcano in the entire solar system, Olympus Mons, which towers 16 miles high, nearly 3 times the height of Mount Everest. This extinct volcano is so massive that if you stood on its summit, its slopes would extend beyond the horizon in every direction, and you wouldn't even realize you were standing on a mountain. Mars also has the deepest canyon in the solar system, Valles Marineris, stretching over 2,500 miles long and up to 4 miles deep. If placed on Earth, it would span the entire width of the United States. Now float peacefully outward to the realm of the gas giants, beginning with Jupiter, the largest planet in our solar system. Jupiter is so enormous that all the other planets could fit inside it with room to spare. It's more than 1,300 times the volume of Earth. Jupiter's most famous feature is the Great Red Spot, a storm that has been raging for at least 400 years. Since before the United States existed, this hurricane has been spinning in Jupiter's atmosphere. The Great Red Spot is so large that 2 or 3 Earths could fit inside it. Yet despite Jupiter's size, it rotates faster than any other planet, completing one day in just under 10 hours. This rapid rotation creates powerful winds and the distinctive bands of clouds we see wrapping around the planet. As you sink deeper into tranquility, consider Jupiter's role as protector of the inner solar system. Jupiter's immense gravity acts like a cosmic vacuum cleaner, attracting asteroids and comets that might otherwise collide with Earth. In 1994, astronomers watched as comet Shoemaker-Levy 9 broke apart and crashed into Jupiter in a spectacular series of impacts. Without Jupiter's protective presence, Earth would likely be struck by large objects far more frequently, making the development of complex life much more difficult. Jupiter is our silent guardian, deflecting dangers we never see. Travel with me now to Saturn, the jewel of the solar system, famous for its magnificent rings. These rings, while spectacular, are surprisingly thin, sometimes less than 30 feet thick, though they extend outward for 175,000 miles. The rings are made of countless chunks of ice and rock, ranging in size from tiny grains to pieces as large as houses, all orbiting Saturn in a flat plane. If you could take all the material in Saturn's rings and compress it together, it would form a moon only about 300 miles across. The rings look enormous, but contain relatively little mass, spread across vast distances like a thin veil of light. Here's something beautiful as you drift towards sleep. Saturn is the only planet in our solar system that is less dense than water. If you could find a bathtub large enough, Saturn would float. This is because Saturn, like Jupiter, is composed mostly of hydrogen and helium, the lightest elements in the universe. Despite being 95 times more massive than Earth, Saturn's density is so low that it would bob on an ocean's surface like a cork, though such an ocean could never exist. It's a reminder that in space, the rules we know from Earth don't always apply, and the universe is full of gentle impossibilities. Let yourself rest now in the realm of these giants, where storms rage for centuries, where rings of ice catch the sunlight, where everything moves in an ancient dance choreographed by gravity's invisible hand. Drift now to the outer reaches of our solar system, where the worlds grow cold and strange, and the sun's light becomes a distant whisper. Let us journey to Uranus, a planet unlike any other, tilted on its side as it orbits the sun. While most planets spin like tops, with their axes roughly perpendicular to their orbits, Uranus is tipped over at a 98-degree angle, rolling around the sun like a ball. This means that for part of its 84-year orbit, one pole points directly at the Sun for 42 years of continuous daylight, while the other pole experiences 42 years of darkness. Scientists believe a massive collision with an Earth-sized object early in the solar system's history knocked Uranus into this unusual orientation. This pale blue-green world, colored by methane in its atmosphere, spins through space in its own quiet, sideways dance. Now breathe slowly and travel outward to Neptune, the windiest planet in our solar system. Despite being the farthest planet from the Sun, nearly 2.8 billion miles away, and receiving only a tiny fraction of the Sun's warmth, Neptune experiences the fastest winds ever recorded, reaching speeds of up to 1,200 miles per hour. These supersonic winds are more than 5 times faster than the strongest hurricanes on Earth. The source of Neptune's violent weather remains a mystery, as the planet receives so little solar energy. It's as if Neptune has its own internal engine, driving storms across its deep blue surface in near total darkness. As you relax deeper into peace, consider the dwarf planet Pluto, once considered the 9th planet, now recognized as the largest known member of the Kuiper Belt. Pluto is a small, icy world about 2/3 the size of Earth's moon, orbiting 3.6 billion miles from the Sun. At this distance, sunlight is so faint that noon on Pluto would look like deep twilight on Earth. Pluto takes 248 Earth years to complete one orbit around the Sun. Since its discovery in 1930, Pluto still hasn't completed even a single orbit. It won't reach the same point in its journey until the year 2178. Time moves differently in the outer solar system, where years are measured in human generations. Let your thoughts drift now beyond the planets, to the Kuiper Belt itself, a vast ring of icy objects extending from Neptune's orbit outward for billions of miles. This is the realm of comets, frozen worlds, and mysteries. Beyond even the Kuiper Belt lies the Oort cloud, a theoretical spherical shell of icy debris surrounding our entire solar system at a distance of nearly 1 light-year from the Sun. The Oort cloud is thought to contain trillions of comets, waiting in the cold darkness. When one of these icy wanderers is nudged by gravity, it begins a long fall toward the Sun, heating up as it approaches and developing the magnificent tail we recognize. Every comet we've ever seen began its journey in this distant, frozen reservoir at the edge of the Sun's influence. Here's something remarkable as you sink into deeper relaxation: a single day on Venus is longer than a year on Venus. Because Venus rotates so slowly on its axis, one complete rotation takes 243 Earth days. But Venus orbits the Sun in only 225 Earth days. This means that a Venusian day, from one sunrise to the next, actually lasts longer than the time it takes Venus to complete an entire orbit around the Sun. Time and motion work in unexpected ways when you venture beyond Earth. Now float peacefully to consider our Milky Way galaxy, the vast collection of stars that contains our solar system. The Milky Way is a spiral galaxy, shaped like a spinning disk with graceful arms curving outward. It contains between 200 and 400 billion stars, though the exact number is uncertain because much of our galaxy is hidden from view by dust and gas. Our solar system resides about 26,000 light-years from the galactic center, in a minor spiral arm called the Orion Spur. We're in the galactic suburbs, far from the crowded downtown of the galactic core. The Milky Way is so vast that light takes about 100,000 years to travel from one side to the other, yet it's just one galaxy among hundreds of billions in the observable universe. As you breathe softly and deeply, consider this: the Milky Way is moving. Everything in space is in motion. The Earth spins on its axis at about 1,000 miles per hour. Earth orbits the Sun at about 67,000 miles per hour. The Sun, carrying Earth and all the planets with it, orbits the center of the Milky Way at approximately 514,000 miles per hour. And the entire Milky Way galaxy is moving through space at about 1.3 million miles per hour, pulled by gravity toward a mysterious region called the Great Attractor. You are not sitting still, you are on a cosmic journey, hurtling through space at speeds that would be terrifying if we could feel them, yet moving so smoothly we perceive only peace and stillness. Finally, let yourself rest with this thought: between Mars and Jupiter lies the asteroid belt, a ring of rocky debris that never formed into a planet. This belt contains millions of asteroids ranging from tiny pebbles to Ceres, the largest, which is about 590 miles across. Despite what science fiction might suggest, the asteroid belt is mostly empty space. If you were to fly through it, you likely wouldn't see a single asteroid. They're spread across such vast distances that collisions are rare. The belt is a reminder that space is defined more by emptiness than by the objects within it, a vast canvas painted with occasional brush strokes of matter, stretching endlessly in all directions. Rest now in this flowing cosmic river, where everything moves together in harmony, where you are part of an ancient dance that began billions of years ago and will continue for billions more. Allow yourself to drift even deeper into the vastness of space, where stars are born and die, where galaxies dance, and where the universe reveals its most profound mysteries. Let us travel now beyond our Milky Way, to the realm of other galaxies. The nearest large galaxy to our own is Andromeda, a spiral galaxy similar to the Milky Way but slightly larger, containing about 1 trillion stars. Andromeda lies 2.5 million light-years away, which means the light we see from it tonight left that galaxy 2.5 million years ago, when our ancestors were just beginning to walk upright on the plains of Africa. Yet despite this immense distance, Andromeda is actually moving toward us. In about 4.5 billion years, the Milky Way and Andromeda will collide, merging into a single, larger galaxy. Don't worry, this collision will be gentle, with vast spaces between the stars. The night sky of that distant future will be spectacular, with Andromeda growing larger and larger over millions of years until the two galaxies embrace and become one. Now, breathe slowly and consider the nature of stars themselves. Stars are born in vast clouds of gas and dust called nebulae, where gravity slowly pulls material together. When enough mass accumulates, the pressure and temperature at the core become so intense that nuclear fusion begins. Hydrogen atoms fuse into helium, releasing tremendous energy. This is the moment a star ignites, beginning its long life of converting matter into light. Our Sun has been doing this for 4.6 billion years, burning about 600 million tons of hydrogen every single second. Yet the Sun is so massive that it can continue this process for another 5 billion years before its fuel runs out. As you sink deeper into tranquility, picture the largest stars in the universe. While our Sun is medium-sized, some stars are unimaginably enormous. The largest known star, Ui Scuti, is a red supergiant with a radius about 1,700 times larger than the Sun. If you placed Ui Scuti at the center of our solar system, its surface would extend beyond the orbit of Jupiter. A single one of these hypergiant stars contains more volume than 1 billion suns. Yet despite their size, these massive stars live fast and die young, burning through their fuel in just a few million years before exploding as supernovae. Let your mind drift now to those supernovae, the spectacular deaths of massive stars. When a star much larger than our Sun exhausts its fuel, it can no longer support itself against gravity's pull. The core collapses in less than a second, then rebounds in a catastrophic explosion that briefly outshines an entire galaxy. For a few weeks, a single dying star can be brighter than 100 billion normal stars combined. These explosions scatter heavy elements, carbon, oxygen, iron, gold, across space. Every atom in your body heavier than hydrogen was forged in the heart of a star or created in a supernova explosion. You are literally made of stardust, the remnants of stars that died billions of years ago, their atoms recycled into planets, oceans, and eventually, you. Here's something beautiful as you relax even deeper. Neutron stars, the remnants left behind after certain supernovae, are among the strangest objects in the universe. A neutron star is typically only about 12 miles across, roughly the size of a city, yet contains more mass than our Sun. The gravity is so intense that a teaspoon of neutron star material would weigh about 6 billion tons on Earth. Neutron stars can spin incredibly fast, some rotate hundreds of times per second, sending beams of radiation out into space like cosmic lighthouses. These are called pulsars, and their timing is so precise that astronomers once briefly wondered if they might be signals from alien civilizations. They're not, they're just the universe's most extraordinary clocks, keeping perfect time as they spin in the darkness. Now float peacefully to consider black holes, regions of space where gravity is so strong that nothing, not even light, can escape. Black holes form when the most massive stars collapse at the end of their lives, compressing their entire mass into an infinitely small point called a singularity. The boundary around a black hole, beyond which nothing can return, is called the event horizon. Despite their fearsome reputation, black holes don't roam space devouring everything in sight. They simply sit in place, and their gravity behaves like that of any other massive object, only dangerous if you get too close. At the center of nearly every large galaxy, including our Milky Way, sits a supermassive black hole containing millions or even billions of times the mass of the Sun. As you breathe softly and let sleep draw near, consider the center of our own galaxy. There, about 26,000 light-years away, lurks Sagittarius A*, pronounced A star, a supermassive black hole with the mass of about 4 million suns. Scientists have watched stars orbit this invisible giant, racing around it at speeds of thousands of miles per second, their paths revealing the presence of something massive yet unseen. In 2022, astronomers captured the first image of Sagittarius A*, not the black hole itself, which emits no light, but the glowing ring of hot gas swirling around it. This image shows the shadow of the black hole silhouetted against the bright material spiraling into oblivion, a window into one of nature's most extreme phenomena. Finally, as you drift into deeper peace, think about the cosmic web, the large-scale structure of the universe. Galaxies are not randomly scattered through space. They're arranged in vast filaments and sheets, surrounding enormous voids where almost no galaxies exist. This structure looks remarkably like a web, with clusters of galaxies at the intersections and long strands connecting them. The voids between can be hundreds of millions of light-years across, regions of space containing almost nothing, dark and empty. The cosmic web is shaped by dark matter, an invisible substance that makes up about 85% of all matter in the universe, its gravity pulling galaxies into these patterns like water droplets following the threads of a spider's web. Rest now in this magnificent architecture, where the universe organizes itself into patterns too vast to see all at once, where gravity weaves everything together, and where you float peacefully among wonders beyond imagining. breathe gently and let yourself float deeper still, into the mysteries of time and space, where the universe reveals its most profound secrets. Let us drift now to the very beginning, the Big Bang, the moment when our universe came into existence 13.8 billion years ago. In that first instant, all the matter and energy that would ever exist was compressed into an infinitely small, infinitely dense point. Then, in a fraction of a second, space itself began expanding, and it has been expanding ever since. The Big Bang wasn't an explosion into empty space, it was the beginning of space itself, the birth of time, the origin of everything. In the first second after the Big Bang, the universe went through more changes than it has in the 13.8 billion years since. Particles formed, forces separated, and the basic rules of physics that govern our universe today were established, all in less time than it takes to blink. Now, as you relax even deeper, consider the cosmic microwave background radiation, the afterglow of the Big Bang itself. About 380,000 years after the universe began, it had cooled enough for light to travel freely through space for the first time. That ancient light has been traveling through the expanding universe ever since, stretched and cooled by the expansion until today it reaches us as faint microwave radiation coming from every direction. This radiation fills all of space and has a temperature of just 2.7 degrees above absolute zero. When you see static on an old television screen, about 1% of that static is actually this ancient light, the echo of creation itself, still whispering through the cosmos after nearly 14 billion years. Let your thoughts drift to the concept of the observable universe. When we say the universe is 13.8 billion years old, you might think we could see 13.8 billion light years in every direction. But the universe has been expanding while light travels through it, stretching the distance. The observable universe, the sphere of space from which light has had time to reach us, is actually about 46.5 billion light-years in radius. This creates a sphere 93 billion light-years across, containing everything we could possibly see. Beyond this cosmic horizon lies more universe, perhaps infinitely more, but it's forever hidden from us because light from those distant regions hasn't had time to reach us yet, and never will because of the universe's expansion. As you sink into deeper tranquility, picture the concept of dark energy, the mysterious force that makes up about 68% of all the energy in the universe. In 1998, astronomers made a shocking discovery: the universe's expansion is not slowing down, as gravity should cause it to do, but actually accelerating. Something is pushing space apart, making galaxies fly away from each other faster and faster. Scientists call this dark energy, but in truth, we don't know what it is. It's one of the greatest mysteries in all of science. This invisible energy is winning the cosmic tug-of-war against gravity, determining the ultimate fate of our universe. Here's something peaceful to contemplate as you drift towards sleep: the speed of light creates a kind of cosmic time machine. When astronomers look at distant galaxies, they're not just seeing far away, they're seeing far into the past. A galaxy 1 billion light-years away appears to us as it was 1 billion years ago. The most distant objects we can observe are more than 13 billion light-years away, appearing as they were when the universe was young, just a few 100 million years old. By looking deeper into space, we look further back in time, watching the universe's history unfold. We can see galaxies being born, stars forming, and the universe evolving, all preserved in the light that has been traveling toward us since ancient times. Now breathe slowly and consider the planets beyond our solar system, exoplanets. The first planet orbiting a sun-like star was discovered in 1995, and since then, astronomers have confirmed more than 5,000 exoplanets, with thousands more waiting to be verified. These worlds come in astonishing variety, Gas giants larger than Jupiter orbiting closer to their stars than Mercury is to our Sun, rocky super-Earths several times our planet's size, water worlds covered in global oceans, and planets orbiting binary star systems where two suns rise and set in the alien sky. Some exoplanets experience temperatures hot enough to vaporize rock. Others are so cold that their atmospheres rain liquid methane. The diversity of worlds in our galaxy far exceeds anything we imagined before we began finding them. Let yourself float peacefully now to consider the habitable zone, sometimes called the Goldilocks zone, the region around a star where conditions are just right for liquid water to exist on a planet's surface. Not too hot, not too cold, but just right. Earth sits comfortably in our Sun's habitable zone, allowing oceans to flow and life to flourish. Scientists estimate that there could be as many as 40 billion Earth-sized planets in habitable zones around Sun-like and red dwarf stars in the Milky Way alone. That's billion with a B, 40 billion potential worlds where liquid water might flow, where conditions might be suitable for life. In the vast tapestry of the universe, Earth may not be unique, but one of countless worlds where the conditions for life exist. Finally, as sleep embraces you, consider that we are living in the stelliferous era, the age when stars shine. This era began a few 100 million years after the Big Bang and will continue for trillions of years into the future. Eventually, though, all the hydrogen in the universe will be used up, star formation will cease, and existing stars will burn out one by one. The universe will grow dark and cold, entering what cosmologists call the degenerate era. But that's so far in the future, trillions upon trillions of years, that it's almost like forever. For now, for an unimaginably long time to come, the universe will be lit by stars, brilliant points of light shining in the darkness, and we are privileged to live in this luminous age, where the cosmos sparkles with light and possibility. Rest now in this age of stars, where light travels across billions of years to reach your eyes, where the universe expands into infinite mystery, and where you float peacefully among wonders that stretch from the beginning of time to the edges of eternity. Let yourself drift even deeper now, into the gentle embrace of cosmic mysteries, where each breath connects you to the infinite expanse of space and time. Picture now the International Space Station, humanity's outpost in the cosmos, orbiting Earth at an altitude of about 250 miles. This remarkable laboratory travels at approximately 17,500 miles per hour, completing one orbit around our planet every 90 minutes. This means that astronauts aboard the ISS witness 16 sunrises and 16 sunsets every single day. Imagine watching the sun rise over the curve of the Earth, bathing the planet in golden light, then 45 minutes later watching it set again, the thin blue line of atmosphere glowing like a halo around the world. The space station has been continuously occupied since November 2000. Making it more than 2 decades of uninterrupted human presence in space, a permanent foothold beyond our planet's surface. Now, as you breathe slowly and peacefully, consider what astronauts experience in the weightlessness of orbit. Without gravity's constant pull, their bodies change in fascinating ways. Their spines stretch, making them up to 2 inches taller in space. Fluids shift toward their heads, giving them puffy faces and thin legs, what astronauts call chicken legs and puffy face syndrome. Their sense of taste diminishes because congestion from fluid shift affects smell, which is essential for taste. Most remarkably, after returning to Earth, it takes months for their bodies to readjust to gravity. Bones that didn't need to support weight in space must rebuild density. Muscles that didn't fight against gravity must regain strength. Astronauts describe the sensation of gravity as feeling heavy, as if wearing a suit of armor, after floating freely for months. Let your thoughts drift now to the moons of Jupiter, a miniature solar system in itself. Jupiter has 95 known moons, but 4 stand out as particularly remarkable: the Galilean moons, discovered by Galileo in 1610. Io, the innermost, is the most volcanically active body in the solar system, with hundreds of volcanoes erupting continuously, some shooting plumes of sulfur 250 miles into space. Europa, covered in smooth ice, hides a liquid water ocean beneath its frozen surface that may contain twice as much water as all of Earth's oceans combined. Scientists believe this subsurface ocean could potentially harbor life, making Europa one of the most intriguing places to search for extraterrestrial organisms in our solar system. As you sink deeper into tranquility, picture Ganymede, the largest moon in our entire solar system, bigger than the planet Mercury. Ganymede is the only moon known to have its own magnetic field, creating aurora at its poles just like Earth does. And then there's Callisto, ancient and heavily cratered, possibly harboring another subsurface ocean. These 4 moons, visible through even a small telescope, are worlds unto themselves, each with unique characteristics, reminding us that our solar system contains not just planets, but dozens of fascinating moons, many of which are more interesting than the planets they orbit. Here's something beautiful as you relax even deeper. The Hubble Space Telescope, launched in 1990, has given us some of the most spectacular images of the universe ever captured. One of its most famous photographs, the Hubble Deep Field, was created by pointing the telescope at a tiny, seemingly empty patch of sky, a region no bigger than a grain of sand held at arm's length, and collecting light for 10 days. When the image was revealed, that empty patch contained about 3,000 galaxies, each containing billions of stars. This single image transformed our understanding of the universe's vastness. Later, the even deeper Hubble Ultra Deep Field revealed about 10,000 galaxies in an equally tiny patch of sky. Nearly everywhere we look, even in the darkest, emptiest seeming regions of space, we find galaxies, islands of stars stretching back to the early universe. Now float peacefully to consider the James Webb Space Telescope, launched on Christmas Day 2021, the most powerful space telescope ever built. Webb observes the universe in infrared light, allowing it to see through dust clouds and detect the faint heat signatures of the most distant galaxies. Its mirror is more than 6 times larger than Hubble's, and it sits not in Earth orbit, but at a point 1 million miles away called L2, where it can observe the cosmos with minimal interference. Webb has already sent back breathtaking images, galaxies from when the universe was only a few 100 million years old, detailed views of exoplanet atmospheres, and stunning portraits of stellar nurseries where new stars are being born. This telescope is showing us the universe as never before, peeling back layers of cosmic history. Let yourself drift now to the phenomenon of gravitational lensing, one of Einstein's predictions come to life. When light from a distant galaxy passes near a massive object like a galaxy cluster, the gravity of that cluster bends the light, acting like a giant lens in space. This can create multiple images of the same distant galaxy, stretched and distorted into arcs and rings around the lensing cluster. Sometimes this creates an Einstein ring, a perfect circle of light surrounding the massive object. But gravitational lensing isn't just beautiful, it's useful. It allows astronomers to study incredibly distant galaxies that would otherwise be too faint to see, magnified by the natural telescope of gravity itself. The universe provides its own tools for exploration. Finally, as sleep draws very near, consider the Voyager spacecraft, Voyager 1 and Voyager 2, launched in 1977. These twin probes have traveled farther from Earth than any human-made objects in history. Voyager 1 has left our solar system entirely, entering interstellar space in 2012, and is now more than 15 billion miles from Earth. Despite this immense distance, the spacecraft still sends back signals, though they take more than 22 hours to reach us, traveling at the speed of light. Each Voyager carries a golden record, a time capsule containing sounds and images from Earth, greetings in 55 languages, and music from different cultures. These records are messages in bottles, cast into the cosmic ocean, carrying a portrait of humanity to anyone who might find them in the distant future. The Voyagers are now humanity's ambassadors to the stars, traveling silently through the void, carrying our story with them into eternity. Rest peacefully now, knowing that even as you sleep, these Voyagers continue their journey, that telescopes gaze into the depths of time, and that the universe unfolds its mysteries moment by moment, invitation to wonders stretching infinitely outward. Drift now into the deepest layers of cosmic wonder, where the universe reveals its most intimate secrets and the boundaries between science and poetry blur into peaceful understanding. Let us travel now to Saturn's moon Titan, one of the most Earth-like worlds in our solar system. Despite being nearly 1 billion miles from the Sun, Titan is the only moon in our solar system with a substantial atmosphere. In fact, its atmosphere is thicker than Earth's, extending 10 times higher into space. But this atmosphere isn't made of the oxygen and nitrogen we breathe. It's primarily nitrogen with clouds of methane and ethane. On Titan's surface, the temperature hovers around -290 degrees Fahrenheit, so cold that water ice is as hard as rock, and liquid methane fills rivers, lakes, and seas. Imagine standing on Titan's shore, watching waves of liquid methane lap against icy beaches, under an orange sky so thick with haze you can barely see the sun. It's a world of familiar processes, weather, erosion, seasons, but made from completely alien materials. Now, as you breathe slowly and deeply, consider the moons of our own planet throughout history. Earth hasn't always had just one moon. About 4.5 billion years ago, a Mars-sized object scientists call Theia collided with the young Earth in a catastrophic impact. The collision was so violent that it melted both bodies, ejecting an enormous amount of material into orbit. This debris gradually came together through gravity, forming our moon. In a very real sense, the moon is made partly from Earth itself, a piece of our planet, torn away and reformed, now keeping watch over us from the sky. Some of the rocks brought back by Apollo astronauts are nearly as old as the solar system itself, preserving a record of that ancient, violent birth. Let your thoughts drift peacefully to the concept of time dilation, one of Einstein's most profound discoveries. Time itself is not constant, it flows at different rates depending on gravity and velocity. Near a massive object like a black hole, time slows down dramatically compared to regions farther away. If you could watch a clock falling into a black hole, you would see it tick slower and slower as it approached the event horizon, eventually appearing to freeze at the boundary, though the clock itself would experience time normally. Astronauts on the International Space Station, moving quickly and experiencing slightly less gravity than on Earth's surface, age about 0.007 seconds less per 6-month stay than they would on Earth. Time is not the rigid framework we once believed, but a flexible dimension, stretching and compressing throughout the cosmos. As you sink deeper into tranquility, picture the red giant phase awaiting our Sun billions of years from now. When the Sun exhausts the hydrogen in its core, it will begin fusing hydrogen in a shell around the core, causing the outer layers to expand dramatically. The Sun will swell to perhaps 200 times its current size, becoming a red giant so large it may engulf Mercury and Venus. Earth, if it survives, will be a scorched, lifeless rock, its oceans long since boiled away into space. But even this isn't the end. Eventually, the Sun will shed its outer layers and beautiful shells of glowing gas called a planetary nebula, leaving behind a dense, hot core, a white dwarf, about the size of Earth but containing half the Sun's mass. This white dwarf will slowly cool over trillions of years, eventually becoming a cold, dark ember drifting through space. Here's something remarkable as you relax even deeper: water is everywhere in the universe. We've found water on Mars, both as ice at the poles and possibly as liquid brine flowing seasonally down crater walls. We've detected water vapor in the atmospheres of exoplanets. We've found ice on Mercury, hiding in permanently shadowed craters near the poles. There's water on Jupiter's moon Europa, Saturn's moon Enceladus, and probably many other worlds throughout the solar system and beyond. Scientists have even detected vast clouds of water vapor in space. One cloud surrounding a black hole contains 140 trillion times more water than all of Earth's oceans. Water, essential for life as we know it, is one of the most common molecules in the cosmos, suggesting that the ingredients for life may be widespread throughout the universe. Now float gently through space to consider the Great Red Spot of Jupiter more closely. This massive storm has been raging for at least 350 years. It was first observed in the 1660s and has been continuously monitored since 1830. The storm is so large that at its widest point, you could fit 2 or 3 Earths inside it. Wind speeds at the edge reach 270 miles per hour. Yet mysteriously, the Great Red Spot has been shrinking over the past century. In the 1800s, it was about 25,000 miles wide. Today it's roughly 10,000 miles across. Scientists don't fully understand why it's shrinking or how long it will last. Perhaps in the coming century, this iconic feature of our solar system will fade away entirely, a reminder that even the most enduring phenomena are temporary on cosmic timescales. Let yourself drift now to the curious phenomenon of solar eclipses, one of the most spectacular cosmic coincidences visible from Earth. Our moon is about 400 times smaller than the Sun, but it's also about 400 times closer to Earth. This means they appear almost exactly the same size in our sky, a perfect cosmic accident. When the moon passes directly between Earth and the Sun, it can cover the Sun's bright disk completely, creating a total solar eclipse. During these few precious minutes, day turns to twilight, stars appear in the afternoon sky, and the Sun's corona, its outer atmosphere, becomes visible as a shimmering halo. Total solar eclipses are rare for any given location on Earth, occurring perhaps once every 375 years. But this perfect alignment won't last forever. As the moon slowly drifts away from Earth, future generations will eventually see only partial eclipses. The moon will be too far away to completely cover the Sun. Finally, as sleep embraces you completely, consider that we are all time travelers, moving forward through time at 1 second per second, but also that everything you see in the night sky is already in the past. The light from the moon is 1.3 seconds old when it reaches your eyes. Light from the Sun is 8 minutes old. The light from the nearest star, Proxima Centauri, is 4.24 years old. When you gaze at the Andromeda Galaxy, you're seeing it as it was 2.5 million years ago. In a very real sense, the present moment doesn't exist in space, there is only the past, arriving at different times, a cascade of ancient light from countless sources, all converging in your eyes this moment, connecting you to times and places separated by unimaginable distances. Rest now in this flowing river of light and time, where past and present merge, where distance and duration become one, and where you float peacefully in the eternal now that contains all moments. Let yourself sink into the deepest peace now, where the cosmos whispers its final secrets and the universe cradles you in infinite gentleness. Drift with me now to the moons of Saturn, where one small world captures the imagination of scientists searching for life. Enceladus, a moon only 310 miles across, small enough to fit across the state of Arizona, is covered in brilliant white ice that reflects nearly all the sunlight that touches it, making it one of the brightest objects in our solar system. But Enceladus holds a secret. Beneath that frozen surface lies a global ocean of liquid water. From cracks near its south pole, enormous geysers erupt, shooting water vapor and ice particles more than 300 miles into space. The Cassini spacecraft flew through these plumes and detected not just water, but organic molecules and salts, ingredients that could support life. Somewhere beneath that ice, in the darkness of that hidden ocean, warmed by tidal forces from Saturn's gravity, there might be life, simple organisms floating in an alien sea we've never seen. Now, as you breathe slowly and peacefully, consider the vastness of the Andromeda Galaxy we mentioned earlier. While the Milky Way contains 200 to 400 billion stars, Andromeda holds approximately 1 trillion stars, that's 1,000 billion individual suns, each potentially with its own family of planets. If you could somehow visit Andromeda and stand on a planet orbiting one of its trillion stars, you would look up and see the Milky Way in that alien sky, a faint smudge of light 2.5 million light-years away, just as we see Andromeda from Earth. Somewhere in that distant galaxy, perhaps on a world not so different from ours, someone might be looking back, wondering if they're alone in the universe, while we wonder the same thing here. Let your thoughts drift to the concept of the multiverse, an idea that stretches even beyond our vast universe. Some theories in physics suggest that our universe might be just one of countless universes, each with potentially different physical laws, different constants of nature, different possibilities. These other universes, if they exist, would be forever separate from ours, unreachable and undetectable. In some versions of the multiverse theory, every possible outcome of every event occurs in some universe somewhere. It's a profound and perhaps unsettling idea, that reality might be far larger than even the observable universe, that existence itself might be infinite in ways we can barely conceive. Yet even this remains speculation, a beautiful mathematical possibility that may never be proven or disproven. As you sink into deeper tranquility, picture the Lagrange points, special locations in space where the gravitational forces of two large bodies, like the Earth and Sun, balance perfectly with the centrifugal force of an orbiting object. There are 5 such points in the Earth-Sun system. The James Webb Space Telescope sits at L2, 1 million miles from Earth, where it can maintain its position with minimal fuel expenditure, always keeping Earth, Moon, and Sun behind it to shield its sensitive instruments. These points are like cosmic parking spots, stable harbors in the gravitational dance between worlds, and we've learned to use them as perches from which to observe the universe. Here's something beautiful as you relax even deeper: the auroras, or northern and southern lights, are caused by particles from the Sun colliding with Earth's atmosphere near the magnetic poles. These charged particles, carried by the solar wind, follow the lines of Earth's magnetic field and funnel toward the poles, where they strike oxygen and nitrogen atoms in the upper atmosphere, causing them to glow. Oxygen produces green and red light, nitrogen produces blue and purple. The result is one of nature's most spectacular light shows, curtains of shimmering color dancing across the night sky. But Earth isn't the only planet with auroras. Jupiter, Saturn, Uranus, and Neptune all have magnetic fields and atmospheres, and all experience their own auroral displays, some hundreds of times more powerful than Earth's, glowing silently above alien clouds. Now float peacefully through space to consider the fate of the universe itself. Based on current observations, the universe will continue expanding forever, growing colder and darker with time. In trillions of years, the last stars will burn out. In even longer spans of time, black holes will slowly evaporate through a process called Hawking radiation, taking googolls of years to disappear completely. Eventually, the universe will reach a state of maximum entropy, where no energy is available to do work, no structure remains, and everything reaches the same uniform temperature just above absolute zero. Scientists call this the heat death of the universe. But this end is so incomprehensibly far in the future, a one followed by 100 zeros worth of years, that it's essentially forever. For now, for spans of time that dwarf all of human history countless times over, the universe will be vibrant and filled with light. Let yourself drift now to consider comets, those icy wanderers that occasionally grace our skies with their spectacular tails. Comets are ancient remnants from the formation of the solar system, frozen balls of ice, dust, and rock that have remained largely unchanged for 4.6 billion years. They're like time capsules, preserving the original material from which the planets formed. When a comet's orbit brings it close to the Sun, the ice begins to vaporize, creating a glowing coma around the nucleus and streaming behind it in magnificent tails that can stretch for millions of miles. There are 2 types of tails: a dust tail, pushed back by the pressure of sunlight, and an ion tail, blown by the solar wind, always pointing directly away from the Sun. Some comets return regularly. Halley's Comet appears every 76 years and has been recorded by humans for more than 2,000 years. Others visit once and never return, flung out of the solar system by gravitational interactions, becoming wanderers in the space between stars. Finally, as you surrender to sleep's gentle embrace, consider humanity's place in this vast cosmos. We are a young species on a small planet, having gained consciousness of the universe only in the last few centuries. We've sent our machines to every planet in our solar system. We've looked back through time to see the universe in its infancy. We've discovered thousands of worlds beyond our own and found that the ingredients for life are common throughout space. We stand at the threshold of understanding, asking the ancient questions: are we alone? How did the universe begin? What is our place in this cosmic story? These questions connect us to every human who has ever looked up at the stars and wondered. The universe is vast beyond comprehension, yet here we are, small but aware, temporary but conscious, part of the cosmos looking back at itself with wonder and awe. Sleep now, peacefully, knowing you are made of stardust, connected to everything, a brief but beautiful expression of the universe's infinite creativity, floating gently in a cosmic ocean that has no shore. Drift now into the deepest stillness, where the last whispers of the cosmos blend into the gentle darkness of restful sleep, and wonder dissolves into peace. Let us travel now to the surface of Mars, where robotic explorers have walked for decades, serving as our eyes and hands on another world. The Curiosity rover, which landed in 2012, and Perseverance, which arrived in 2021, are not just rolling cameras, they're sophisticated mobile laboratories the size of small cars. These rovers have drilled into Martian rocks, analyzed their chemistry, and discovered something remarkable: Mars once had conditions suitable for life. Ancient riverbeds, dried lake beds, and minerals that only form in the presence of water tell a story of a warmer, wetter Mars billions of years ago. The Perseverance rover is even collecting samples of Martian rock and soil, carefully storing them in tubes that a future mission might bring back to Earth. These samples could answer one of humanity's most profound questions: did life ever exist on Mars? Now, as you breathe slowly and deeply, consider the phenomenon of meteor showers, those magical nights when dozens of shooting stars streak across the sky. These aren't actually stars, of course, but tiny pieces of debris, usually no larger than grains of sand, left behind by comets as they orbit the Sun. When Earth's orbit intersects with these streams of debris, the particles enter our atmosphere at tremendous speeds, burning up in brilliant flashes of light. The Perseid meteor shower, visible every August, comes from debris left by comet Swift-Tuttle. The Geminids in December come from an asteroid called Phaeton. During peak viewing times, you might see 50 to 100 meteors per hour, nature's fireworks display, tiny fragments of cosmic travelers burning up 60 miles above your head, creating light that has traveled billions of miles through space to reach your eyes. Let your thoughts drift peacefully to the concept of cosmic rays, high-energy particles that constantly rain down on Earth from deep space. These aren't rays at all, but atomic nuclei, mostly protons, traveling at nearly the speed of light, carrying enormous energy. Some cosmic rays come from our Sun, but the most energetic ones originate in supernovae, neutron stars, and possibly even black holes. They've been traveling through space for millions of years before striking Earth's atmosphere. Right now, as you rest, cosmic rays are passing through you, about 1 per second, striking every square centimeter of your body. Most pass through harmlessly, though they can occasionally cause a single pixel in a digital camera to light up. The camera has detected a cosmic ray that began its journey when dinosaurs walked the Earth, perhaps longer ago still. As you sink into deeper tranquility, picture the dwarf planet Makemake, one of the distant icy worlds beyond Neptune. Discovered in 2005 and named after the creation deity of the Rapa Nui people of Easter Island, Makemake orbits the Sun at an average distance of about 4.2 billion miles, taking 305 Earth years to complete one orbit. Its surface is covered in frozen methane and ethane, giving it a reddish-white color. The temperature there hovers around -406 degrees Fahrenheit. In 2016, scientists discovered that Makemake has a tiny moon, now called 2 Malawian kwaches, which orbits the dwarf planet in about 12 days. These distant worlds, only recently discovered, remind us how much of our own solar system remains unexplored, how many mysteries still hide in the outer darkness, waiting to be found. Here's something profound as you relax even deeper: the elements that make up your body were created in different cosmic events over billions of years. The hydrogen in your body, making up about 10% of your atoms, was created in the Big Bang itself, 13.8 billion years ago. The carbon, nitrogen, and oxygen, the building blocks of life, were forged in the cores of massive stars and scattered across space when those stars died as supernovae. The iron in your blood was created in the final seconds before a supernova explosion, in one of the most violent events in the universe. The gold in any jewelry you wear was likely created in the collision of two neutron stars, an event so energetic it distorts space and time itself. You are not just in the universe, you are a collection of cosmic moments, atoms gathered from across space and time, temporarily organized into the form of a thinking, feeling being. Now float gently through space to consider gravitational waves, ripples in the fabric of spacetime itself. When massive objects like black holes or neutron stars orbit each other and eventually collide, they create waves that spread outward at the speed of light, stretching and squeezing space as they pass. Einstein predicted these waves in 1916, but they weren't detected until 2015, when the LIGO Observatory recorded waves from two black holes colliding 1.3 billion light-years away. The detection was so sensitive that it measured a change in distance smaller than 1,000th the width of a proton. Since then, we've detected dozens of these events, each one a cosmic collision sending ripples across the universe. We're now listening to the universe in a completely new way, detecting events we could never see with light alone. Let yourself drift now to the beautiful concept of the pale blue dot, a photograph taken by Voyager 1 in 1990 when it was 3.7 billion miles from Earth, at the edge of our solar system. At the request of astronomer Carl Sagan, the spacecraft turned its camera back toward home and took a photograph. In that image, Earth appears as a tiny speck, less than a single pixel, suspended in a beam of scattered sunlight. That pale blue dot contains everything we've ever known, every person who has ever lived, every civilization, every triumph and tragedy, every hope and dream. As Sagan wrote, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives on that mote of dust suspended in a sunbeam. It's a humbling perspective, a reminder of both our smallness and our preciousness, a call to cherish this fragile world and care for each other. Finally, as sleep wraps around you completely, consider that the story of space exploration is ultimately the story of curiosity and hope. 50 years ago, humans walked on the moon. 12 people in total have stood on that alien surface and looked back at Earth hanging in the black sky. Today, we're planning to return to the moon and venture to Mars. We're building telescopes that will see even further into space and time. We're searching for signs of life on distant moons and exoplanets. Each discovery reveals that the universe is stranger, more beautiful, and more wondrous than we imagined. And every question we answer raises new questions, deeper mysteries, further horizons. The exploration never ends, it only expands, like the universe itself, forever growing, forever revealing new wonders. Rest now, completely and deeply, floating among these infinite wonders, cradled by the cosmos, part of the eternal story that stretches from the beginning of time to this peaceful moment, and beyond. Let yourself sink into the final depths of peaceful rest, where the universe's gentlest mysteries lull you into the deepest, most restorative sleep. Drift with me now to the zone of totality during a solar eclipse, that magical path where the moon's shadow touches Earth. This shadow, called the umbra, races across the Earth's surface at speeds exceeding 1,000 miles per hour, though from space it appears as a small, dark circle gliding across the planet. Within the shadow, for a few precious minutes, day becomes night. The temperature drops, birds return to their roosts thinking evening has arrived, and planets and bright stars appear in the darkened sky. Ancient civilizations feared eclipses, seeing them as omens or celestial battles. Now we understand them as beautiful demonstrations of orbital mechanics, yet they remain no less awe-inspiring. The next total solar eclipse visible from the United States will occur in 2044. Mark that date in your dreams, a future moment when day will briefly surrender to an unexpected night. Now, as you breathe slowly and peacefully, consider the asteroid Bennu, a small world about 1,600 feet across, roughly the height of the Empire State Building. In 2020, NASA's OSIRIS-RX spacecraft gently touched the surface of Bennu and collected a sample of its ancient material. This sample, delivered to Earth in September 2023, contains pristine material from the early solar system, including organic compounds and minerals that have remained unchanged for 4.5 billion years. By studying Bennu's composition, scientists can understand what the solar system was made of before planets formed, like reading the first pages of a story that eventually led to Earth and life. This small, dark asteroid, tumbling through space, carries within it the memory of our cosmic origins. Let your thoughts drift peacefully to the phenomenon of space weather, the invisible storms that rage through our solar system. The sun doesn't just send light and heat, it also emits a constant stream of charged particles called the solar wind, flowing outward at speeds of about 1 million miles per hour. Sometimes, the sun releases massive eruptions called coronal mass ejections, sending billions of tons of plasma hurtling through space. When these storms strike Earth's magnetic field, they can create spectacular auroras but also disrupt satellites, radio communications, and power grids. In 1859, a massive solar storm called the Carrington event created auroras visible as far south as the Caribbean and caused telegraph systems worldwide to fail, with some even catching fire. If such a storm struck today, in our technology-dependent world, the effects would be far more severe, a reminder that we live not in empty space but in the sun's dynamic, ever-changing domain. As you sink into deeper tranquility, picture the ring system of Saturn more closely. While Saturn's rings are the most famous, they're not permanent features. Scientists believe they may be relatively young, perhaps only 100 million years old, formed from the breakup of a moon that wandered too close to Saturn and was torn apart by tidal forces. The rings are constantly evolving, with tiny moonlets called shepherd moons using their gravity to sculpt the ring edges and create gaps. Material from the rings is slowly falling into Saturn's atmosphere as ring rain, pulled down by the planet's gravity and magnetic field. At the current rate, Saturn's rings might disappear entirely in another 100 million years. The magnificent rings we see today are a temporary decoration, a fleeting cosmic jewelry that won't last forever, another reminder that even the most iconic features of our universe are impermanent. Here's something beautiful as you relax even deeper, the concept of a light echo, a phenomenon where we see the same astronomical event multiple times. When a star explodes as a supernova, it sends out a burst of light in all directions. Some of this light travels directly to us, arriving first. But some light travels outward, strikes clouds of dust and gas in space, and reflects toward us, arriving years or even centuries later. This reflected light allows us to see replays of ancient stellar explosions, watching them unfold again like cosmic instant replays. Astronomers have observed light echoes from supernovae that occurred centuries ago, each echo revealing new details about these spectacular events. It's as if the universe keeps recordings of its most dramatic moments, playing them back for anyone patient enough to watch. Now float gently through space to consider the Horsehead Nebula, one of the most iconic and beautiful structures in our galaxy. Located about 1,500 light-years from Earth in the constellation Orion, the Horsehead is a dark cloud of dense dust and gas, silhouetted against a bright emission nebula glowing with the light of nearby hot stars. The Horse's head shape is purely coincidental, we see it only from our particular vantage point in the galaxy. From another star system, it would look completely different, perhaps not resembling a horse at all. This nebula is a stellar nursery, where new stars are forming from the collapse of dense pockets of gas. Inside the densest parts, hidden from view, baby stars are being born this very moment, adding to the 200 billion stars already shining in our galaxy. Let yourself drift now to the moons of Uranus, all 27 of them, uniquely named after characters from the works of William Shakespeare and Alexander Pope rather than figures from Greek and Roman mythology. Miranda, the smallest of Uranus's 5 major moons, is one of the strangest worlds in our solar system. Its surface looks like it was assembled from mismatched pieces, regions of different ages and textures stitched together in a geological patchwork. One area has cliffs up to 12 miles high, nearly twice the height of Mount Everest, the tallest known cliff faces in the entire solar system. Scientists believe Miranda may have been shattered by a massive impact early in its history, then reassembled under its own gravity, creating this Frankenstein-like world, a moon that was broken and put back together, carrying the scars of ancient violence. Finally, as sleep's deepest peace settles over you completely, consider this last gentle thought: the night sky you see is a gift that connects you to every human who has ever lived. For hundreds of thousands of years, our ancestors looked up at the same stars, wondered about the same mysteries, and felt the same sense of awe. The constellations they saw are essentially unchanged. Orion still hunts across the winter sky, the Big Dipper still points the way north, the summer triangle still marks the warm season's nights. Though we now understand that stars are distant suns, that galaxies stretch beyond counting, and that the universe is vaster than our ancestors could have imagined, the stars themselves remain faithful companions, anchoring us to the cosmos and to all of humanity's long journey through time. When you look up at the night sky, you're participating in the oldest human tradition, the first science, the original wonder. And in that moment, past and present unite, and you are home among the stars. Sleep now, deeply and peacefully, wrapped in stardust and dreams, floating gently through the infinite universe that holds you safe, knowing that when you wake, those same patient stars will still be watching, still shining, still calling us to wonder. Drift now into the final embrace of cosmic peace, where the last secrets of the universe whisper softly, guiding you into the deepest and most restful sleep. Let us journey one more time to Venus, that cloud-covered world, to discover something unexpected. A day on Venus lasts 243 Earth days, but high in Venus's atmosphere, something remarkable happens. The thick atmosphere rotates around the planet much faster than the planet itself spins, completing a full rotation in just 4 Earth days. This phenomenon, called superrotation, creates winds that race around Venus at speeds up to 220 miles per hour, while the surface far below remains relatively calm. It's as if Venus wears a coat of wind that spins independently of the planet itself, atmospheric mystery scientists are still working to fully understand. Even in our own cosmic neighborhood, worlds continue to surprise us with their complexity. Now, as you breathe slowly and deeply, consider the dwarf planet Haumea, one of the strangest objects in our solar system. Located beyond Neptune in the Kuiper belt, Haumea spins faster than any other known large object in the solar system, completing one rotation every 4 hours. This rapid spin has stretched Haumea into an elongated, egg-like shape. It's about as long as Pluto but only half as wide. Imagine a world shaped more like a football than a sphere, tumbling end over end through the outer darkness. Haumea also has 2 small moons and, remarkably, a ring system, the only dwarf planet known to have rings. This distant, spinning, ring-adorned world reminds us that the outer solar system is filled with exotic objects waiting to reveal their secrets. Let your thoughts drift peacefully to the concept of the habitable zone around different types of stars. We've mentioned the habitable zone around Sun-like stars, but most stars in the galaxy are red dwarfs, smaller, cooler, and much longer lived than our Sun. A red dwarf can shine for trillions of years, compared to our Sun's 10 billion-year lifetime. The habitable zones around red dwarfs are much closer to the star, meaning planets there would orbit their Sun in just a few weeks rather than a year. On such a world, you might see your star as a large, reddish orb hanging in the sky, and if the planet is tidally locked, with one side always facing the star, you would have eternal day on one hemisphere and eternal night on the other, with a narrow twilight zone between where conditions might be just right for life. As you sink into deeper tranquility, picture the Great Attractor, a mysterious gravitational anomaly in deep space. Our Milky Way galaxy, along with hundreds of thousands of other galaxies, is being pulled toward this region at speeds of millions of miles per hour. The Great Attractor lies about 150 million light-years away, behind the disk of our own galaxy, making it difficult to observe directly. What creates this immense gravitational pull? It appears to be an enormous concentration of mass, possibly a massive cluster of galaxy clusters. But beyond the great attractor lies something even larger, the Shapley supercluster, containing tens of thousands of galaxies, which may be the true source of this cosmic current. We are all flowing through space, carried by invisible forces toward distant shores we can barely detect. Here's something profound as you relax even deeper: the Hubble constant, which measures how fast the universe is expanding, has presented scientists with a puzzling problem. When astronomers measure the expansion rate using nearby galaxies, they get one answer. When they measure it using the cosmic microwave background radiation from the early universe, they get a different answer. The two methods shouldn't disagree, yet they do. This discrepancy, called the Hubble tension, suggests either our measurements have subtle errors, or, more excitingly, there's something fundamental about the universe we don't yet understand. Some unknown physics, some hidden component of reality, might be waiting to be discovered. The universe still holds mysteries that challenge our understanding, reminding us that science is an ongoing journey, not a finished destination. Now float gently through space to consider Olympus Mons on Mars once more, but this time its full context. This shield volcano is not only the tallest mountain in the solar system but also one of the youngest large volcanoes, perhaps only a few 100 million years old. Unlike Earth, where tectonic plates move and volcanoes shift location, Mars has no plate tectonics. A volcanic hotspot on Mars stays in one place for billions of years, allowing lava to pile up higher and higher, building mountains of extraordinary height. Olympus Mons is so massive that if you stood on its peak, the base would lie beyond the horizon in every direction due to the curve of Mars's surface. It's a volcano the size of Arizona, a mountain so large it defines the very shape of the planet beneath it. Let yourself drift now to a beautiful cosmic coincidence. The Earth's diameter is approximately 7,918 miles, and the Moon's diameter is approximately 2,159 miles. If you add those together, you get 10,077 miles. The Sun's diameter is about 864,000 miles, roughly 108 times the Earth's diameter, and the distance from Earth to the Moon is about 238,855 miles, roughly 108 times the Moon's diameter. These mathematical relationships, pure coincidence though they may be, create the perfect conditions for the spectacular total solar eclipses we experience. The universe is filled with such numerical harmonies, patterns that feel almost musical, as if reality itself is composed according to hidden mathematical principles that occasionally reveal themselves in these elegant ratios. Finally, as you surrender completely to sleep's embrace, consider the overview effect, a profound shift in perspective experienced by astronauts who view Earth from space. From orbit, national borders disappear. The atmosphere appears as a thin, fragile shell, thinner than the skin of an apple relative to its size. Earth seems small, delicate, isolated in the vast darkness, yet stunningly beautiful, a jewel of blues, greens, and whites hanging in the void. Astronauts report that seeing Earth from this perspective fundamentally changes how they think about humanity and our place in the cosmos. Our differences seem smaller, our common humanity more apparent, our shared home more precious. This shift in consciousness, this cosmic perspective, is perhaps one of the greatest gifts of the space age, the ability to see ourselves as we truly are, one species, one world, together on a small but precious planet, floating through the infinite cosmos. Rest now in complete and total peace, embraced by the universe that created you, part of the cosmic dance that began 13.8 billion years ago and continues in this very moment, in your breath, in your dreams, in the gentle darkness that holds all things. Sleep deeply, sleep well, knowing you are home among the stars, always have been, always will be. Good night, cosmic traveler. The universe keeps watch while you rest. Let yourself dissolve into the final moments of cosmic wonder, where the gentlest truths of the universe carry you into the deepest sanctuary of sleep. Drift with me now to the realm of quasars, among the most luminous and distant objects in the observable universe. A quasar is powered by a supermassive black hole at the center of a distant galaxy, actively feeding on surrounding material. As matter spirals into the black hole, it heats to millions of degrees, releasing tremendous energy, so much that a single quasar can outshine an entire galaxy of hundreds of billions of stars. The most distant quasars we observe are more than 13 billion light-years away, meaning we see them as they were when the universe was less than 1 billion years old, in its infancy. These brilliant beacons from the early universe show us that supermassive black holes formed surprisingly quickly after the Big Bang, revealing a universe that evolved faster and more dramatically than we once imagined. Now, as you breathe slowly and peacefully, consider Neptune's moon Triton, one of the most unusual and fascinating moons in our solar system. Triton is the only large moon in the solar system that orbits in the opposite direction of its planet's rotation, a retrograde orbit. This backward motion tells us that Triton didn't form alongside Neptune but was captured from the Kuiper belt, a dwarf planet stolen by Neptune's gravity and forced into servitude. Triton is geologically active despite temperatures of -391 degrees Fahrenheit, with nitrogen geysers erupting from its surface, shooting material up to 5 miles high. This captured moon, orbiting backward, slowly spiraling inward, will eventually, in perhaps 3.6 billion years, be torn apart by Neptune's gravity, creating a spectacular ring system that may one day rival Saturn's. Let your thoughts drift to the space between galaxies, the intergalactic medium. This isn't truly empty space but is filled with an extremely tenuous gas, mostly hydrogen, at a density of perhaps 1 atom per cubic meter, far more empty than the best vacuum we can create on Earth, yet still not absolute nothingness. This gas is heated to temperatures of millions of degrees by the energy released from galaxies and quasars, creating a hot, diffuse plasma that permeates the cosmos. Through this thin medium, galaxies move like ships through a cosmic ocean, their passage creating subtle waves and disturbances that spread across millions of light-years. Even the voids, the emptiest regions of space, contain this whisper-thin gas, connecting all things. As you sink into deeper tranquility, picture the planet HD 189733b, an exoplanet about 64 light-years from Earth. This gas giant orbits incredibly close to its star, completing one orbit every 2.2 days. The planet is tidally locked, with one side forever facing the star, heated to over 1,800 degrees Fahrenheit. But what makes this planet truly remarkable and terrifying is its weather. Strong winds race around the planet at speeds up to 5,400 miles per hour, about 7 times the speed of sound. Even more remarkably, the planet's deep blue color isn't from water but from silicate particles in its atmosphere. It rains glass on this world, sideways, at thousands of miles per hour. Imagine standing on such a planet, if you could, as molten glass droplets hurl past at supersonic speeds under a scorching blue sky. The diversity of worlds in our universe extends to nightmares as well as dreams. Here's something beautiful as you relax even deeper. Pulsating variable stars called Cepheids serve as cosmic measuring sticks. These stars brighten and dim in regular cycles, and remarkably, the period of their pulsation is directly related to their true brightness. By measuring how long it takes a Cepheid to complete one cycle, days or weeks, astronomers can calculate how bright it truly is. By comparing that true brightness to how bright it appears from Earth, they can determine exactly how far away it is. This relationship, discovered by Henrietta Swan Leavitt in 1912, opened the door to measuring the universe. Cepheid variables are the first step on the cosmic distance ladder, allowing us to gauge the vast scales of space, to map our universe, to understand our place in the grand cosmic architecture. Now float gently through space to consider the Van Allen radiation belts, 2 donut-shaped regions of charged particles trapped by Earth's magnetic field. The inner belt, discovered in 1958, extends from about 600 to 3,700 miles above Earth's surface. The outer belt reaches from about 7,500 to 36,000 miles up. These belts are filled with high-energy protons and electrons, captured from the solar wind and cosmic rays. They protect us by trapping harmful radiation that would otherwise reach Earth's surface, yet they also pose a hazard to satellites and astronauts. During particularly strong solar storms, the radiation belts can swell and intensify, becoming dangerous zones that spacecraft must carefully navigate. Earth's magnetic field, invisible and often forgotten, is one of the key reasons our planet can support life, a shield against the radiation-filled cosmos. Let yourself drift now to the curious case of dark matter candidates. Scientists have proposed numerous possible explanations for dark matter, that invisible substance that makes up 85% of all matter in the universe. One candidate is WIMPs, weakly interacting massive particles, hypothetical particles that rarely interact with normal matter. Another is axions, even more elusive particles that were originally proposed to solve a different physics problem. Some scientists suggest dark matter might be primordial black holes formed in the first moments after the Big Bang. Others propose modified theories of gravity that would eliminate the need for dark matter entirely. Despite decades of searching with increasingly sensitive detectors, dark matter remains stubbornly invisible, one of the greatest unsolved mysteries in physics. The universe keeps this secret close, revealing its effects, the motion of galaxies, the structure of the cosmos, while hiding its true nature. Finally, as you surrender to the deepest sleep, consider the concept of cosmic time. The universe is 13.8 billion years old, but from the perspective of a photon traveling at the speed of light, no time passes at all. According to Einstein's relativity, time slows down as you approach the speed of light, and at exactly the speed of light, time stops. A photon emitted from a star billions of years ago experiences no passage of time during its journey to your eye. From its perspective, its creation and absorption are the same instant, an eternal now. In this way, all light exists in a timeless state, connecting the past and present in a single moment. As you close your eyes and drift into sleep, you carry with you this profound truth: the universe is both ancient and immediate, vast yet intimate, eternal yet present in each fleeting moment. And you, made of atoms forged in stars, conscious and aware, are the universe experiencing itself, a temporary form through which the cosmos knows its own existence. Sleep now, completely, deeply, infinitely peacefully. The universe cradles you in its ancient embrace. Stars shine on while you rest. Galaxies turn in their slow dance. And you are safe, you are home, you are exactly where you're meant to be, a child of the cosmos, returning to dreams, floating gently in the infinite ocean of space and time that has no beginning and no end. Settle now into the very deepest peace, where the final whispers of cosmic mystery dissolve into pure tranquility, and the universe itself becomes your lullaby. Let us drift one last time to Saturn's moon Enceladus, to explore what makes this small world so extraordinary. Beneath its icy crust, Enceladus harbors not just water, but a warm ocean heated by tidal forces from Saturn's gravity. The moon is constantly being squeezed and stretched as it orbits, generating friction and heat deep within, enough to keep a liquid ocean beneath miles of ice. The geysers that erupt from the South Pole shoot water at speeds up to 800 miles per hour, and within those plumes, scientists have detected not just water and organic molecules, but also molecular hydrogen, a sign that chemical reactions are occurring between the ocean water and the rocky core below. These are the kinds of reactions that could provide energy for life, the same reactions that fuel certain microbes in Earth's deep oceans. In the darkness beneath that ice, warmed by tidal heating, chemistry is happening that mirrors the chemistry of life itself. Now, as you breathe with perfect slowness, consider the star Betelgeuse, the red supergiant that marks the shoulder of Orion the Hunter. Betelgeuse is one of the largest stars visible to the naked eye. If placed at the center of our solar system, its surface would extend beyond the orbit of Mars. This aging giant has exhausted the hydrogen in its core and is now burning heavier elements, approaching the end of its stellar life. At any time, tomorrow, or 10,000 years from now, Betelgeuse could explode as a supernova. When it does, it will briefly become as bright as the full moon, visible even during the day, and will remain visible for months. This cosmic firework, when it comes, will have actually occurred 650 years earlier. That's how long light takes to reach us from Betelgeuse. Somewhere in the future, perhaps in your lifetime, perhaps in your descendants' lifetime, the night sky will gain a brilliant new star, and humanity will witness one of nature's most spectacular events. Let your thoughts drift to the Voyager golden records in more detail, those messages to the cosmos. Each record contains 116 images showing Earth's diversity, from mathematical definitions to photographs of humans, animals, and landscapes. There are greetings in 55 languages, including ancient Sumerian and modern Mandarin, from hello to peace to friends of space. How are you all? Have you eaten yet? The sounds of Earth are there too: wind, thunder, birds, whales, a baby crying, a kiss, laughter. Music spans cultures and centuries: Bach, Mozart, Beethoven, Chuck Berry, traditional songs from around the world. There's even the sound of human brain waves, recorded from a person meditating on love and Earth's history. These golden records will outlast Earth itself. In 5 billion years, when our sun becomes a red giant and consumes our planet, the Voyagers will still be sailing through space, carrying the story of a world that once was, of people who once looked up and wondered. As you sink into the deepest tranquility, picture the Lagrange point L4 and L5, the 2 points that form equilateral triangles with Earth and Sunday. These points are naturally stable. Objects placed there tend to stay there, trapped in a gravitational equilibrium. And indeed, Earth's L4 and L5 points have collected dust and small asteroids over billions of years. Some visionaries have proposed these as ideal locations for space colonies, massive rotating cylinders where thousands of people could live, with artificial gravity provided by rotation, bathed in sunlight reflected by mirrors, growing food and internal ecosystems. These space habitats, proposed by physicist Gerard O'Neill in the 1970s, could be humanity's future beyond Earth, not on hostile planet surfaces, but in carefully crafted worlds at the stable points of gravitational balance, where we could build whatever environment we choose, free from the constraints of planetary surfaces. Here's something gentle as you relax towards sleep: the moon is gradually slowing Earth's rotation. The moon's gravity creates tidal bulges in Earth's oceans, and as Earth rotates beneath these bulges, friction occurs, very slowly draining rotational energy. This means Earth's day is getting longer, by about 1.7 milliseconds per century. When the dinosaurs walked the Earth, a day was about 23 hours long. A billion years ago, an Earth day was only 18 hours. In the distant future, Earth's rotation will slow so much that Earth and Moon will become tidally locked to each other, just as the Moon is already locked to Earth. At that point, billions of years from now, a day on Earth will equal a month, and the Moon will hang motionless in the sky, visible from only one hemisphere, eternally fixed in position. Time flows not just forward, but slower, as the cosmos gently applies its brakes. Now float peacefully to the concept of habitable exomoons. We've discussed exoplanets extensively, but moons orbiting those planets could also harbor life. In our own solar system, the most promising places to find life are moons, Europa, Enceladus, Titan. Around other stars, gas giants in or near habitable zones could have large, rocky moons with atmospheres and liquid water. A moon orbiting a gas giant might experience eclipses as it passes through the planet's shadow, creating regular day-night cycles even if the moon is tidally locked to its planet. From such a moon's surface, you would see your planet hanging huge in the sky, going through phases like our moon does, with multiple other moons visible as bright points of light. The sky would be a constantly changing celestial drama, with eclipses, transits, and the dance of sister moons creating a night sky more dynamic and spectacular than anything we see from Earth. Let yourself drift now to the stellar classification system, a beautiful taxonomy of stars. Stars are categorized by temperature and color using letters O, B, A, F, G, K, M, a sequence memorized by generations of astronomers using the mnemonic "Oh, be a fine girl/guy, kiss me." O-type stars are the hottest and bluest, with surface temperatures over 50,000 degrees Fahrenheit. M-type stars are the coolest and reddest, around 5,000 degrees. Our Sun is a G-type star, yellow and medium temperature. Each type has its own character. Blue giants burn fiercely and die young, red dwarfs glow gently for trillions of years. This system brings order to the stellar chaos, revealing that stars are not all the same but represent a spectrum of possibilities, each type playing its own role in the cosmic story, together creating the rich tapestry of the galaxy. Finally, as you surrender to sleep's complete embrace, consider one last profound truth: the atoms in your left hand likely came from different stars than the atoms in your right hand. Stars of different masses produce different elements. Massive stars create heavy elements like iron and gold, while smaller stars produce lighter elements like carbon and oxygen. Supernovae scatter these elements across vast distances. The atoms that eventually came together to form your body were created in multiple different stars, scattered across space, drifted through molecular clouds, condensed into our solar nebula, formed Earth, cycled through air and water and food, and finally assembled into you. You are not just made of stardust, you are made of many different stars, a cosmic mosaic, a living collection of stellar history, temporary but precious, conscious and aware, a way for the universe to know itself. Rest now in complete peace, in perfect stillness, in infinite comfort. You have journeyed through billions of years, across billions of light years, from the beginning of time to the present moment. Now let that journey dissolve into dreams, let wonder transform into rest, let the vastness of space become the intimacy of sleep. The universe holds you. The stars keep watch. And in the morning, when you wake refreshed and renewed, all of this will still be true. You will still be made of stars, still part of the cosmic dance, still a child of the universe. But for now, simply rest. Simply sleep. Simply be. Good night, beloved traveler. Good night, rest now in complete and total peace, embraced by the universe that created you, part of the cosmic dance that began 13.8 billion years ago and continues in this very moment, in your breath, in your dreams, in the gentle darkness that holds all things. Sleep deeply, sleep well, knowing you are home among the stars, always have been, always will be. Good night, cosmic traveler. The universe keeps watch while you rest.